Welcome to my YouTube channel. Today I'm talking about standard deviation. Okay, so standard deviation is a measure of the spread of your dataset. Not like variance, although standard deviation is in more interpretable units. Variance is in square deviation from the mean, so the average square deviation from a mean, whereas standard deviation is not average deviation from the mean. Although if you did a different calculation of using absolute values, you do get different results, but that doesn't matter. We don't use absolute values, we use square deviations and then take the square root of that. So anyway, so to calculate standard deviation, you do basically all the same things for variance with one extra step. Okay, so you take the average of the dataset, you subtract the mean for each data point and square the result. You sum all the squared differences. You then divide the number of data points by n for a population, or n minus 1 for a sample standard deviation. I missed the word sample. Okay. And then you take the square root of that to go from variance to standard deviation. Okay, so this is a population standard deviation. If your population is quite small and you have all the values for a population you're interested in, I keep using the example of undergraduate CPA at a certain college. Someone knows everyone's CPA at a certain college, and they can take the standard deviation of that. And that would be a population standard deviation because they're not interested in other colleges, they're only interested in their college. Okay, so you have the sum of the values minus the mean of those values squared divided by n. Notice that's a mu, not an x bar, because this is a population. And if you are calculating a population standard deviation, you have the population mean. So that's why it's mu and not x bar. And it's much more likely that you're working with a sample that's not the whole population you're interested in. You have x bar, which is a sample mean. And those two computations are identical, but the notation can be important. So you do the exact same thing, but instead of divided by n, you divide by n minus 1. And as I talked about in the variance video, literally a second ago for me, you do that because sample variances and standard deviations would otherwise underestimate the variability in the sample. When you take a sample from a population, you lose those extreme values somewhat, and the n minus 1 is a way to compensate for that. As n gets larger, the effect of minus 1 diminishes, but for smaller samples, the minus 1 serves to increase the estimate of the variability closer to what the population would show. Okay, so let's get to an example of calculating standard deviation. We have the same few numbers. You add them up, divided by the number of numbers you added up. You get 80. You go through, it's not like the variant example. You take each value, subtract the mean, and you square them. You do that for each number. And then you add them all up. Divide by n, or n minus 1. This is n for the population, but it would be n minus 1, or 4, for the sample. And then the very last step that makes the variance a standard deviation, you take the square root of the variance. So the square root of this number 50 is 7.07. And this is a more intuitive way to think about the spread of the data. So we expect about 95% of the data to fall plus or minus 2 standard deviations. So 14. And so if we think about that, I'm going to do 15. That's because I'm doing this on the spot. So 65 would be the low point. Yeah. And then 95 would be the high point. That seems about right. Okay. What the heck have I done? Okay. I somehow went back one. Brilliant. Okay. Where am I at now? Okay, so basically standard deviation is more interpretable. You would have a hard time interpreting square deviations and making arguments based on that. Standard deviation makes that easier. Standard deviation is still susceptible to outliers, but not as much. And you're always going to use it. You don't really have a better option between standard deviation and variance. You're going to use a standard deviation. It's just what we use. So we could talk about the pros and cons of it, but you're going to use it, and that's how you do it. Okay. So, that's the end of the video. Thank you for watching.